Matplotlib has kind of this duality of APIs set up. You have this very implicit API, which is from PyPlot, and then you have a kind of an explicit, maybe more object-oriented API. In addition, there's a second dimension, a second layer that adds to this confusion. There's a convenience and a verbose layer. This is how I phrase them. The convenience layers are your things just like plt.plot. You want to make a plot just super quick, no code almost, and you get something that looks decent, right? When you're just trying to eyeball your data, this is the way to go. However, there is a more verbose layer, something where you can really try and make those fine-tuned adjustments to your plot, setting the X ticks in the right way, setting the labels, the titles, etc., in the way that you really want it to communicate results. So, an example of this implicit but also convenient API is something like the PyPlot interface. In this example, I've set up just some x's spanning from -5 to 5, and then I have cubed those values, and I can, in one line of code, I can produce a result. I can produce a plot. This is fantastic, right? I don't need to really think about the visualization. All I'm saying is just plot these x's and y's as a line and just show me what comes out. This is the type of plot that I would reach for when I'm just trying to get a feel for my data, and I don't necessarily care about, sending this off to my boss or sending this off to some external party and say, hey, this is what these data mean. This is just something I can use internally, just very convenient. I don't need to write a lot of code just to achieve something fairly basic. Now, there is a more verbose layer. You can tap into these specific objects that Matplotlib seems to have called axes and figures, and these are the things that actually control where you're going to plot, and you can adjust some parameters on these things to really make those fine-tuned changes, but this is an implicit layer, and the reason I call this implicit, we can make the same plot and it's more verbose. We use just a few more lines of code here to do the actual plotting. But the reason that this is an implicit API is because I'm using this figure object. And in Matplotlib, the figure object is kind of like your sheet of paper, right, if you were to liken it to that. On your sheet of paper, I want to draw a set of axes, right, a plot with an X and Y axis. And I can't tell you where on this figure I'm going to put it necessarily, or that it's even on the figure. But Matplotlib, the PyPlot interface, makes this very simple but also implicit. What's happening here behind the scenes is that I'm creating this figure, this blank canvas, fantastic. And then, just by calling this axes function, I am actually adding a set of axes to that figure. And note that there's no linkage here explicitly that I've put to say that I'm putting this set of axes on this figure. So it's implicit, right, because this figure is kind of a global state that we don't directly manipulate. And then we're using that implicit state, right, that implicit global state, and we're adding a set of axes on it. And then with that axes, this is where we do our actual plotting. So this is an implicit interface because we don't have control, or we're choosing not to control that global state in an explicit manner. There's also what I call an explicit but convenient layer. And now in this, I still instantiate my figure just as I did before. This is largely convenience, and I'll get to that in a minute. But what you're seeing here now is I'm using a method called addSubplot. And I'm using this to generate my axes instead of using that high-level pyplot.axes method. And what you gain here is that I'm now expressing this direct linkage between the axes and the figure. And you can think when you're drawing, right, you want to know what you're drawing on at all times. And when you know what you're drawing on, you'll be able to have this really powerful view of Matplotlib because you'll be able to put titles, you'll be able to put text or markers wherever you want them, and they show up where you expect them to. Whereas with some of that implicit API, it's a great convenience, but it sometimes will produce unexpected results. Things don't show up where you expect them to. There is also a more explicit and verbose layer. And this layer I like because this gives you full control of where the axes are set on the figure. I'm still using this figure as an entry point. I absolutely love figure as an entry point, and I'll show you all of my favorite Matplotlib entry points to start a figure and some axes. But what we're using here now is the add axes method. And this tells us where we should put the axes on the figure. So if we think of our figure as this blank sheet of paper, it actually has a scaling to it, or you can think of proportions. It goes from 0 to 1 on its x dimension and 0 to 1 on its y dimension. And so here I'm saying add a set of axes whose bottom left corner is at 0.1, 0.1, and the width and height of this set of axes goes by 0.8. And so you can see that I can do this, and I can produce a figure that takes the entire screen. Now, what I like about the verbosity of this interface is that I can also add other axes in very arbitrary positions. I can actually use this to inset a set of axes. And what's great about this is the parent axis has no idea that the child or the inset axis is there, and so I can draw on them completely independently of each other without having to worry about them clashing too much. I do have to be careful not to draw under the inset axis because any points on the parent axis won't show up, but you can use this as some type of visualization as a setup to say, you know, maybe you have a lot of data on the parent axis and your inset axis is just kind of like a little magnifying glass or a blown up view. This is something that you would more so use if you're creating maybe an infographic or communicating some very specific results. I wouldn't ever really use this approach if I'm just trying to do the quick and dirty data exploration view of what's going on. Next, when we use things like high-level interfaces, such as pandas.plot, we have access to massive convenience. I can create a data frame with some values, and I can simply call .plot, and I get this graph that has all of my values as lines, right? This is a line chart of prices, let's say. And you can see here that if I'm just trying to eyeball what these data are and what these might mean, I can see that they diverge really strongly past August of 2020. They get a little tangled from May to August, and they start off just a little bit different than each other. But when it comes to making kind of fine-tuned adjustments to this plot, I might want to say, hey, instead of putting them on the same axes, I want to separate these two. I want to really visualize what these two look like without having that overlap between them. And so from this view, I'm really able to see, okay, I can see the range of my data very well. I can see that A goes from about 100 to 300 at its maximum, and B goes from 200 to 600. And so you can use these convenience layers to really power your exploratory data visualizations. What comes into a little bit of an issue is when you try to, say, make fine-tuned adjustments to these plots. I want to set an X label and a Y label on both of these subplots here. Actually, let's go back to my first plot. I want to set an X and Y label on my first plot. Oh man. My plot has fully disappeared. I see X ticks that are just overlapping, right? January seems to have 0.0 on top of it. This looks awful. And so what you can see here is that by using this axes interface to try and set properties on my plot, I'm actually creating a new axis on top of the one that Pandas created implicitly for me. And it's a blank set of axes, and that's why my plot just doesn't have any data on it anymore. So maybe I do a little bit of Googling and I see, okay, set P, that's the thing I want. Stack Overflow, I asked somebody, how can I change the attributes of a given plot in Matplotlib, and they told me set P. And when I run this, oh man, I have a title, I have my X label, I have my Y label. This looks great. But maybe I want to do this for both of my subplots I make when I use the subplots equals true parameter. And I use set P, and I'm hoping my title, my X and Y, they're all there, but just for one of my plots. And you see that when we start using these very convenient layers and intermixing some high-level interface with some implicit Matplotlib interface, we don't have the control over the plots that we think we do or that we want to do. that we want. And so if I were to set these axes or set these parameters correctly, I would have to understand that what this high-level plotting interface returns to me and where the entry point is to the Matplotlib figure and to its axes that's being generated for me from this high-level interface. Lastly, I am no way, shape, or form hating on the PyPlot interface. It is absolutely fantastic. There are a few entry points that I choose to use from it, and you'll probably understand why I feel this way if you have ever tried to create a Matplotlib figure without using PyPlot. If you don't use PyPlot and you just tap into the underlying figure object, create it from scratch, right, without using PyPlot, you'll even notice that figures have a .show method on them. And if you try and run this, you see, oh man, figure.show works only for figures managed by PyPlot, normally created by pyplot.figure. Matplotlib is just telling me at this point to just use PyPlot to set up your figures. And the reason this is because Matplotlib is not just a static plotting library. It's not a one-to-one representation of a plot that'll come out in a JPEG. It has to be transformed. There's a lot of pipe plumbing that happens from Matplotlib's front end that we use here with things like figure to the underlying backend. Matplotlib has many, many different backends that you can kind of plug and play with. There's ag, tkag, there's an interface for wxPython. You can just straight export it to a PNG, completely circumventing the graphical user interface backends. And what these do are all of these windows that are popping up that you're seeing when I create a plot. These are actually the backend rendering my plot for me. You'll notice that I have fun little widgets down here. I can actually pan axes and things like that. I can reset it. And that's because Matplotlib is actually starting up a graphical user interface for me to let me explore my data. And you can think that all of that connectivity, the plumbing that connects the front end to the back end, is not straightforward. It's very complex. And this is the greatest convenience that PyPlot gives us, is that it takes care of that plumbing for us and allows us to just focus on the code that does the plotting and not have to worry about physically connecting, right, the front end layer to tkag specifically and then doing the rendering and drawing onto the canvas. This is the convenience that Matplotlib gives us. It allows us to just focus on the code that creates the plots and ignore the code, for a large part, that connects the front end to its own back end. And so this is why I always say to use the PyPlot interface, because it works for you and it takes care of so much behind the scenes work that you don't need to think about when you're just trying to make a simple plot.